Hi, my name is Tae-Kwon. We introduce a comprehensive framework for egocentric interaction recognition using Merkle's 3D annotations of two hands manipulating objects. Hands pose and object pose are important to understand first-person interaction. However, collecting a dataset with 3D hand poses and 60 object poses is not only expensive but also difficult. Therefore, we collected a new dataset called H2O. Our dataset provides synchronized multi-view RGBD images, action labels, object classes, ground truth 3D poses for left and right hands, 60 object poses, camera poses, object meshes, and scene point clouds. In order to collect the ground truth labels for both hands and object, we used multiple cameras and jointly optimized the pose of hands and object. The existing image-based datasets with 3D annotations for hand interaction either have markers in the region of interest, or are purely synthetic, or capture only one hand without an egocentric view and action labels. Our dataset, H2O, has a large size compared to other image-based datasets with 3D annotations for hand interactions. H2O provides a total of 571K frames captured from 5 different views. It's the first dataset which fully annotated for both hands meshes and object meshes without markers in the region of interest for hand interactions in an egocentric view. To collect the dataset, we optimized the following loss function jointly for hands and object that minimizes surface distance, 2D distance, physical constraint, etc. Let me explain the pipeline. We calibrated camera pose using 9 IR spheres, created object mesh using bed slam, estimated object poses, and optimized hand pose jointly. After that, we manually corrected both hands and object poses and smoothed the poses temporarily. With the fully annotated dataset, we further propose a method to predict action labels by estimating the 3D pose of two hands and the 60 pose of the manipulated object jointly from RGB images. Our method, Topology-Aware Graph Convolutional Network, in short, TAGCN, models both inter- and intra-dependencies between both hands and object by learning the topology of a graph convolutional network that predicts interactions. We parameterize both hands and object poses as individual graphs and combine them in a single multi-graph architecture. We then learn the interdependencies and connections between different graph entities with an adaptive architecture and compute the topology of the multi-graph structure for recognizing 3D hand-object interactions. The result of TAGCN outperforms other image-based methods, which demonstrate the effectiveness of our method and the importance of the 3D pose prediction facilitated by our dataset. Having precise hand and object pose annotations and meshes, our dataset further facilitates modeling hand-object contact. We visualize the contact maps of our dataset using a histogram, counting the number of neighbors for each vertex. In conclusion, we propose a method to collect a dataset of two hands manipulating objects for first-person interaction recognition. Also, we propose the first method to jointly recognize the 3D poses of two hands manipulating objects and a novel topology-aware graph convolutional network for recognizing interaction. Thank you for listening to the presentation.